Hello everyone, this is Jeff Wilkerson, astronomer at Luther College again. Welcome to the second in our series of things to observe in the night sky as I practice making videos for my class each week this fall. We're going to talk about the week of August 31st, Monday, August 31st, and the week following. And I think we'll focus our attention this week. Last week we looked at the moon moving past the bright planets. This week I think we'll focus our attention on Cassiopeia rising in the north. And for those of us here in northeast Iowa, good time to go out and observe is probably between 9 and 10 o'clock in the evening to look at some of the stuff we're going to talk about here today and to look almost due north to see Cassiopeia climbing over the horizon. Cassiopeia will look something like a W with the left side of the W lying down a little bit weakly like that. That's a rough freehand drawing of what Cassiopeia might look like. And to say, to look at Cassiopeia, as you wait a little bit later in the night as it rises, Perseus will come up behind Cassiopeia, and Perseus looks a little bit like a sweep of stars with a couple strands of legs coming down this direction. I've probably drawn that a little bit to the right of where that is, maybe more over this direction. And so you get these stars coming down as leg stars this direction. Goodness, let's just start from scratch here. And to say we'll get a sort of sweep of stars that looks like this. That, by the way, if you look at what you got right there, this looks sort of like a J, and this looks sort of like a W. And as I tell my students all the time, I'm certain that that's just a random coincidence to see my initials etched in the sky like that. And so, but the sweep of arms of Perseus with a couple of strands of legs coming down this way, there's Algol, the demon star, an eclipsing binary star like we study, so we'll talk about that some. And so the sweep of arms of Perseus points at the back of Cassiopeia. We always start to see this rise this time of year when the U.S. Open tennis tournament is going on, and so it looks to me like Perseus is throwing a ball up into the air and about to serve it into the back of his partner Cassiopeia. But halfway between them, and again this spacing is not to scale right now, but about halfway between them lies the double star cluster, two open star clusters. Get an open star cluster. All of the stars in an open star cluster were born out of the same cloud of gas at the same time. Very interesting objects to study. We are studying one in Sagittarius for our research project, so we're interested in these kinds of things. And about halfway between that space, again, that space is bigger than what I've drawn on the board right there, but halfway between them, you'll see that double cluster. The double cluster is bright enough that you can see that with your naked eye in a good dark sky. I remember one November night lying out in the mountains in California when I lived in California, and it was pretty cold that night, so lying in my sleeping bag and not sleeping a whole heck of a lot, and I could see the double cluster very clearly. M31, the Andromeda galaxy, not too far away over here in Andromeda, and M33, a much fainter galaxy in the constellation Triangulum. And I could see all three of those making progress across the night as I was lying there waiting for it the sun to rise and it to warm up just a little bit. But anyway, so this is a good object to go out and see. If you don't see it with your naked eye, if you take binoculars and scan from Perseus up to Cassiopeia, you will see those very clearly. Binoculars are great. Open star clusters. Binoculars are great for observing these kinds of clusters. Open star clusters live in the plane of our galaxy like this. And when we're looking in this direction, if we're out here, we're looking not toward the center, but more toward the anti-center, away from the center of the galaxy, back this direction. But it's a rich band of stars in through here that form the Milky Way galaxy. So this is all part of the disk of the Milky Way galaxy. So you'll see lots and lots of fun glittering stars in there, and the double cluster pops out. Open star clusters can have anywhere from a few tens of stars, or even less than that, to many thousands of stars in them, relatively loosely packed, and you'll see the individual glittering stars in your binoculars. And you should definitely look for that in this coming week or this coming couple of months. And so these clusters, so figuring out which stars are actually in the cluster is a game of probability of making various measurements of things like proper motion and photometry and color spectroscopy, and trying to understand, building certain diagrams to understand where these which of these stars are most likely to be members of that cluster, actually in that cloud of gas that formed those stars at the beginning. And so you'll get various estimates of how many stars are in here, but this is a very rich pair of clusters. And so these run into the thousands for sure. So there are thousands of stars in each of these clusters that you will see reported in various places. Go look up pictures of these clusters. This is the double cluster in Perseus, also known as NGC 884 and NGC 869. So you could look those up as well that way, NGC 869 and 884. And you look at the pictures and you'll see why it's hard to understand membership. There are just so many stars in this region that some of those stars are a little more distant or a little closer, and they are not part of that cluster. A couple of other great clusters in this region. M103 is right here, next to this star in Cassiopeia. So you've got M103, and M52 lies out here. So if you go this distance from the right edge of the W of Cassiopeia, move out the same distance again, you'll come to M52. These are binocular objects. If you got your binoculars and you're scanning in that region, just to the left of the left bottom W star, you'll find M103, and M52 is moved from the bottom right of the W up to the star at the top of the right, and then on up, and you'll find M52. This M52 is the richer of the clusters and the more interesting to look at for sure. M52, if we do a membership estimate of it, it's probably got at least 200 stars in it, and estimates for M103 vary, but I think modern estimates would put it between 150 and 200 stars. But this is a more distant cluster, so these stars are fainter, and it's a little more widespread. So it's a little more sprawling a cluster. This is a little tighter, more interesting visually cluster to look at. But a great thing to be doing with your binoculars out there is looking at these open star clusters in this region. Now, open star clusters living in the disk of the galaxy, something I'm sure we'll talk about again. Open star clusters living in the disk of the galaxy can have all kinds of different ages. They're born out of clouds of gas in the disk of the galaxy, and that's an ongoing process. And so the ages of open star clusters can range from very old. Think about 13.7 billion year history of the universe, and you can get up 10 billion years, 9 billion years in our galaxy here probably would be an old star cluster, and they could be very young. As soon as they've blown away that shroud that they're born from, so you can see into the stars, you can see them, and so they can be maybe a few million years old. All of these clusters that we're looking at here, the double cluster, M103 and M52, are a little bit on the younger side of clusters. So they're a little bit younger than the average cluster, but they're not super young clusters. And again, ages of clusters, estimates for the ages of clusters vary, and you can find different estimates out there, but this is probably somewhere on the order of 10 or 11 million years for the double cluster. And on the order for M103, on the order of 22 million years, let's say, and on the order of about 60 million years for M52, although you'll see estimates that are twice that for M52. So all of these are somewhere from about 10 to 100 million years old. Again, think about the sun at 4.6 billion years old, and you realize 100 million years isn't that old for a cluster. So they're relatively young clusters, even though we might have trouble determining the age explicitly, perfectly. But we know they're on the young edge like that. Some resources to look at these, to look at this data. The data, these estimates for ages, about 11 million years, 22 million years, and 60 million years, 58 million years. Those come largely from a resource I love to go to is webda.muni.cz. And that is there's a physics in there, webda.physics.muni.cz. And that, or just Google WebDA, and that'll give you information, what our sort of best current knowledge estimates of things like ages and distances and stuff for all of these clusters that you see. Another resource that I use a lot when I'm thinking about star clusters that we want to look at and maybe study is that book, Star Clusters, by Archinal and Hines. It's a few years old now. I don't know. I assume it's still in print. I'm not sure. You see it's Wilman Bell Press. Right there. And so if you're interested in studying open star clusters, and you can find clusters, globular star clusters in here as well, but we'll talk more about those another time. So for the week ahead, look at Cassiopeia, look at Perseus pointing at the back of Cassiopeia, and see if you can find these open star clusters. Open star clusters are great. We'll talk more about what they help us understand about the history of stars and the history of the universe. Thanks for checking in, and we'll find something new to talk about next week. Take care, everybody.